What challenges face observing distant exoplanets clearly? Imagine trying to see a tiny firefly next to a blazing floodlight from thousands of miles away. That's similar to the challenge scientists face when trying to observe distant exoplanets. These planets orbit stars that are often billions of miles away, and they are incredibly faint compared to their host stars. The star's brightness can be millions to billions of times stronger than the light reflected or emitted by the planet itself. This makes it very hard to pick out the planet's signal from the overwhelming glare of the star. To do this, scientists use special tools like coronagraphs and starshades that block or reduce the star's light. But making these tools work perfectly is very tricky. They need to be extremely precise and stable to prevent scattered light from hiding the planet. Another big challenge is that exoplanets are very close to their stars in the sky, so telescopes need to have very high angular resolution. This means they must be able to distinguish between two objects that are very close together. Space telescopes also have to stay perfectly still and avoid vibrations or temperature changes that can blur the images. Achieving this level of stability is difficult and requires advanced engineering. The technology needed to directly observe exoplanets is still being developed. Large space telescopes with complex instruments have to undergo rigorous testing on Earth, which is hard because we cannot perfectly simulate space conditions. Sometimes multiple spacecraft work together, like Starshade missions, which adds more complexity in guiding and controlling the system. Detecting the atmosphere of an exoplanet involves measuring tiny spectral signals of gases like water vapor, methane, and oxygen. These signals are faint and can be affected by stellar activity, such as star spots or temperature variations on the star's surface. This stellar noise can make it hard to tell if the signals come from the planet or the star itself. The size of the telescopes needed to see Earth-like planets can be larger than what current rockets can carry into space. Building and launching these massive observatories is a big challenge, and some ideas include assembling them in space. But this process is complicated and costly. Finally, observations are affected by background noise from various sources like stray light, detector noise, and dust around other stars called exozodiacal dust. These can obscure the faint signals from exoplanets. To get clear data, scientists need to carefully calibrate their instruments and use advanced data processing techniques. All these hurdles show why observing distant exoplanets clearly is so difficult. It requires continuous innovation in telescope design, optics, spacecraft control, and data analysis. Future missions will need to make breakthroughs in these areas to better understand worlds beyond Mars and our solar system.